Hey guys, let's talk about the overload in this lesson. Now, it's a pretty odd looking piece of equipment, but once you get the hang of it, they are easy to use. Let's first look at how it works, and then we'll look at how to use it in a circuit. Okay, an overload relay, such as this one, is a unit that detects the amount of current flowing through it. If the current running through it goes above its overload setting, it trips out. Let's break it down. At the top here, we can see 3 pins. These individual pins run through the overload and come out at the bottom where we see T1, T2 and T3. These conductors that go through are not switched like the contactor. They remain a solid connection between here and here inside the overload at all times. So what does this thing do then when it trips out? Well, I'll show you. The magic is in these terminals here at the front of the overload. These are the trip contacts. What these do is, these change state once the overload has detected an overcurrent in at least one of the phases running through it. And it only needs to see overcurrent across one phase to trip out, not all 3. Although overcurrent on all 3 phases will obviously trip the overload out as well. Now, we know these fault contacts change state when the overload detects overcurrent. But what amount of current is that? Well, that can be selected with our dial here on the front. If the motor we are protecting draws 9 amps at full load, then we would usually set this dial here to 9 amps. And if that motor was to draw more than 9 amps on any phase for a period of time, then the overload will trip, the normally open contact will close, and the normally closed contact will open. And that's the key there, guys. Now, this button here is the manual reset. You can also set the overload to auto reset, but I prefer manual reset so that I know when there is a fault. And this button here is the stop. This button changes the state of the normally closed fault contact when pressed, but it doesn't change the state of the normally open fault contact. That's just the way this overload has been set up. Some other brands are similar, some are different. Now, we know how the overload works, but how do we use it in a circuit to protect our motor? The way an overload protects the motor is in conjunction with a contactor. Let's connect it to our contactor and have a look at how it actually protects the motor. Okay, so we've connected the contactor and overload together. Let's protect the motor. So as we know, the contactor is basically a switch to provide power to a motor. And we turn the contactor on and off via our A1 and A2 terminals, in other words, our contactor coil. So all we need to do to protect the motor is take the control voltage signal that goes to the contactor coil and run it through the normally closed fault contacts here. Let's think about what that will do. While the overload is not detecting an overcurrent, these fault contacts will be in their normal state. This will allow our control voltage to continue through and onto the contactor coil, which will energize the contactor. This then closes the contactor contacts, providing a path for the 3 phases to go through the contactor and thus through the overload and onto our motor that we are protecting. Now, if that motor were to suddenly become overloaded and the overload detected an overcurrent situation, the fault contacts would trip out and change state, thus preventing the control voltage from now getting to the contactor coil and thus de-energizing the contactor, which will prevent the 3 phases from getting to our motor to stop it from burning out. Now, I know some people are going to ask me if you can run the neutral through the fault contacts or whereabouts in the circuit you might break the control active. Well, what I will say is this. I prefer to run my control active through my overload fault contacts, but I'm not saying that you can't run your neutral through there instead. What I will say is, providing the wiring rules of your country permit it, of course, whatever you do, I would keep it uniform throughout your whole installation. What I mean is, so if you're running your control active through your fault contacts, then do that for each overload in your switchboard. If you're running your neutral through there, then I would wire all the overloads the same way in your board. Make sense? You don't want to run one neutral through one overload and then one active through another overload, and it'll just be a big mess. You don't want that. And that's basically the idea of the overload relay. As we go further, we're going to learn how to wire these up in a full installation. I'll catch you in the next lesson. Cheers.